Hello, pre-algebra. Mr. Lawrence here with your flipped lesson. We're going to do a little more with perms and combos. Remember, we have a quiz tomorrow. All right, 10 friends go to the movies. If they are all going to sit in the same row, how many different ways can they sit by each other? That should say sit, not sight. Let me see if I can fix that. There we go. All right, so we should be good. Although you can't see it now, but you know it says sit. All right, so I've got 10 friends, and they're sitting in 10 seats, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, and remember, I've told you we've got to decide if it's a perm or a combo. We know the numerator is going to look like that. If it's a combo, there's going to be a denominator. Well, there's two problems here. Think about this. Two ways to think about this. We are not counting how many different ways they can watch the movie. There's only one way to see the movie. We're talking about them sitting next to each other. So for example, you might have person A next to B next to C, but then again you might have C, then B, and then A. And then you might have C, A, and B. And so they're different arrangements of the people. Those situations are perm. When we're lining things up, those things are perms. Okay. Another way to think about it is if you treated it as a combo, and I actually I need to divide 10 spaces upstairs by 10 spaces downstairs, so I need 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All those would cancel out, and therefore there would only be one way for the friends to sit next to each other. Now, let's pretend that Bobby is sitting right here, and Bobby does not shut up during the movie. Okay? And he's driving these two people crazy. Okay? Is that the same as if Bobby's on the end over here, where Bobby could only drive this person crazy? No, it's not the same at all. So this is definitely a perm any way you slice it. Let me get rid of some of these extra things here so that I can go ahead and solve my perm. Now certainly you can use your calculator to handle this for you, and all you have to type in is 10 factorial, right? You don't have to multiply it all out. 10 factorial will get you the answer. And hold on one second. Okay, 10 factorial is quite a large number, and it comes out to be this. Let me put my commas in, then I'll read it. 3,628,800 different ways that you could arrange those 10 friends in the 10 seats at the movie theater. Now, follow-up question for you. What if Bob and Larry must sit in the first two seats by the aisle? Now, we're assuming that you don't go to both aisles, okay? So we're assuming 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to assume that Bob and Larry must go in either of these two seats. And it doesn't really matter how they do it. And we're going to pretend the aisle is here. Okay, and we're going to pretend that there are other seats here that aren't used. That's not an aisle on that side. Okay, well, this is really an easier version of the problem. Because how many people are left to sit in this seat? Well, there's 8. Once somebody's there, there's 7, 6, 5, 4, 3, 2, 1. Of course, we don't multiply by Bob and Larry. We just leave them there, and we do 8 factorial, which ends up resulting in 40,320. Okay, let's switch gears and go to a different type of problem here. And in this problem, you need to pick a numerical password that has 5 digits. Maybe you're signing up for something new online. Your favorite numbers are 2, 4, 7, and 9, 7, 8, and 9. You will only use these 5 numbers, and you will not repeat any of these numbers. How many different passwords can you make? Well, first decide, is it a perm or a combo? Maybe I choose 2, 4, 7, 8, 9. But mistakenly, I type in 9, 8, 7, 4, 2. Do I get into my account? Absolutely not. The order matters. So this is a permutation situation. So I'm going to be picking 5 things. Ask myself, how many choices do I have for the first number? I have 5. Then I have 4, I have 3, I go down 2, I go down to 1. Because I'm not repeating. This is 5 factorial, which comes out to be 120 on the nose. Simple problem, right? Question for you. How many of these passwords are odd? You know, it ends in 1, 3, 5, 7, or 9. Well, you could try to list them all, but you'd have to list 120 and then count them up. I don't want to do that much work. What I want to do is I want to say, you know what, this one right here has to be an odd number. And I know that of 2, 4, 7, 8, and 9, there's 2 odd numbers. I'm going to put a 2 in here because there's 2 choices for the odd numbers. Now, once I've done that, how many do I have left to choose from for the first digit? I only have 4 left because I put one of the odd numbers in the last spot. Then once I've chosen that, I'm down to 3, I'm down to 2, I'm down to 1. That is not 4 factorial. I have to do 4 factorial times 2. I could do that. I could write it as 4 factorial multiplied by 2. Or I could do 4 times 3 times 2 times 1, which is pretty easy. And this will end up being 48. Well, how many must be even? There's a simple way to do it, but we're going to do it using the permutation method, just like we did the last one, and then we'll use our simple way to check it. All right, so this one's got to be even, which means the numbers must end in 0, 2, 4, 6, or 8. Well, of the numbers 2, 4, 7, 8, 9, 3 of those are even. So I'm going to put a 3 there. And then I go back to the first digit and say, well, there's 4 choices. I've already picked one of the even numbers, and then there's 3, and then there's 2, and then there's 1. Multiply those. I could do 4 factorial times 3 if I wanted to, because this part here is 4 factorial. And then I'd have to multiply by the 3 from over here. I could do it that way. And when I do that, I end up with 72. Okay, now I mentioned that easy way before. Let's test something here. Let's see what 48 plus 72 equals. Well, 8 and 2 is 10, and carry the 1, 11, 1 is 12, is 120 different ways. And that matches the answer to the first part of the question, how many different 5-digit combinations can you choose? Or passwords, I should say. All right, that's it for today. Mr. Lawrence signing off. Remember, you do have a test tomorrow. Good night, everybody.